Welcome back. This is another exciting episode of Mr. Takeda Teaches Algebra, but in this case, it's statistics again because we are in lesson 11.4 on two-way tables or two-way data tables, or whatever you want to call them, two-way frequency tables. Um, what are these things? Well, let's take a look. We'll just kind of dive right into it. Let me just say that there's a lot of kind of vocabulary heavy. There's a lot of vocabulary happening in this lesson because there's some things that are very specific to two-way data tables, and they all kind of sound alike. So make sure you take good notes on the names of things. All right. So the first thing, uh, this is a two-way data table. It's a frequency table. You collect data, and it can be split into two different categories. So, for example, in this data table shown here, they asked a bunch of students whether or not they had mobile access, a mobile plan for their phone, I suppose, and they can be divided. The people they talk to could be divided into their class, freshman or sophomore class. This is one category. The second category was whether or not they had mobile access, and that splits down, of course, into yes and no. Since we have two responses here and two responses here, we have this area in the data table of four, in this case, four grids, or four rectangles in the grid, let's say, and we call those joint frequencies. Joint frequencies. I use the word joint to remember that's where two things come together, such as a joint in your body or a joint in your plumbing system in your house. Two pipes come together, we call that a joint. So two things come together, the answer for the mobile access question or the age question, and we call those joint frequencies. Okay. There's also something called marginal frequencies, and those are just the sums of the rows or sums of the columns. So let's take a look at what that looks like. It'll look something like this. Now, in this example, we're just asked to find and interpret the marginal frequencies for the two-way table. And so this is this two-way table we just looked at, and I've added some boxes over here. We might put a title on here like total and total, because the marginal frequencies are just the totals of the rows and columns of the joint frequencies. So working across 55 plus 22, 77 is the marginal frequency for freshmen. In other words, there were just 77 freshmen that were answered this poll. And for sophomores, we'll add them up. 63 and 12 would be 75, sorry. 3 plus 2 is 5, 75. Then we can add up the columns. This is 34. So a total of 34 people did not have mobile access. And over here, 8 and 118 people did have mobile access. And again, these are the marginal frequencies. And in this bottom right-hand corner, if I add it up left to right or up and down, it'll add up the same, 152. So 152 people were answered this poll, or answered this, poll, survey. All right, so those are marginal frequencies. So remember, take good notes. These are joint frequencies. Those are joint frequencies. And these are marginal frequencies. All right? All right. Label them. I didn't write them down. You write them down. Okay, and now we've got these two new terms, joint relative frequency and marginal relative frequency. Well, when we see the word relative, to me that generally means when things are kind of compared to each other. And a joint relative frequency, now I hate this definition I took from the book. It's the ratio of a frequency that is not in the total row or the total column. What does that mean? Well, those are what? The things that are not in the total row or total column are the marginal frequencies. So they're not marginal frequencies. In other words, these are the joint frequencies. So these are joint frequencies. It's the ratio to the total number of values or observation. So in other words, the box in the bottom right-hand corner. A marginal relative frequency is the sum of the joint relative frequencies in a row or column. So we're going to add them up, going up and down or left and right. Okay, and we can express those as either decimals or percents. You can express them as either decimals or percents. So what's that going to look like? Let's take a look. So over here, we have that same two-way table about major. Oh no, I'm sorry. This is a different one. We had that other one was about. I'm sorry. That the other one was a data plan. This is different. So we have this just this raw data here. The joint frequencies about they asked kids that were either juniors or seniors whether or not they were going to major in a medical field in college, and these are the joint frequencies. The results. So in order to continue, the first thing I have to do is to put marginal frequencies in here because I need to divide by column and I need to divide by the total. So let's take a look. Okay, so right there, they just magically popped up for you there. I created the marginal frequencies and the total. So when we want to calculate joint relative frequencies, it's the joint frequency divided by the total, and the total is going to be this one. Right? So here we go, 124 divided by 681. This is 101 divided by 681. This is 219 divided by 681. And this is 236 divided by 681. And as I said on the previous screen, we can express these as either a decimal or a percent. I'm going to do decimals. Boom. There you go. Those are the joint relative frequencies expressed as decimals. Now, the marginal relative frequencies, those are the joint. So here's the marginal relative frequencies. We're just going to add these up left and right and up and down. Okay, so this will be 0.33. This will be 0.65. This will be 0.50, and this is also 0.50. Okay, something's not right in here, I think. Oh, this is 0.67. That's where my mistake is. Sorry about that. Because they should add up left and right, up and down, the same. And they should add up to 100%. So there we go. Okay, so those are our marginal relative frequencies. Marginal relative frequencies. The sum of the joint relative frequencies. All right? And now we've got something called conditional relative frequencies. It's the ratio of a joint relative frequency to a marginal relative frequencies. Joint relative frequency to marginal relative frequency. So again, we're just going to divide the joint by the marginal. And so let's take a look at what we're going to do here. So this is the one we just did, but it's all kind of nice, right? This is the one we just did. So this says to make a two-way data table that shows the conditional relative frequencies based on column totals. All right. So I won't actually be needing these. I just need the column totals here. So let's see. This will be 0.18 divided by 0.33. So that's my column total here. 0.18 divided by 0.13. 0.15 divided by 0.33. 0.32 divided by 0.67 and 0.35 divided by 0.67. And those are going to be, okay, so those are our conditional relative frequencies. So for example, here, take a look at that. And given that a student is not planning to major in a medical field, so in other words, we're only looking at the data here, right? This is the condition is, what's the condition? That a student is not planning to major in a medical field. The conditional relative frequency that he or she is a junior is about 48%. Okay, so the way we look at this data is we consider the condition. In this case, the condition. So since we divided by the column totals, right? The columns have to do with majoring in a medical field. So given that a student is not majoring in a medical field, the conditional relative frequency is 48%. Okay, so here's a frequency table. Actually, I'm going to save the next couple examples in class. We can talk about them a little bit in deeper. But we got the nuts and bolts of this down, and so we can create all the tables. But the last few examples have to do with evaluating them. So we'll save those for in class. Hope you got some good notes here. Again, I know all these terms sound kind of the same. But make sure you have good examples for what each of these things are, especially that conditional relative frequency thing. All right, thanks a lot. Have a great rest of your day. Bye-bye.